This is the second part of section 0-2 real numbers. Now we are going to look at how to identify if a number is less than or greater than, and then we're going to reduce some square roots. One way to understand if a number is less or greater than a different number is by looking at a number line. Once you understand the number line, you can also will use the less than or the greater than symbols. And after we talk about those less than greater than, we're going to talk about perfect square numbers to approximate a radical or a square root. So let's go ahead and look at the number line. We know the number line has the zero, usually is in the middle, and you have negatives on the left side of the zero, positives on the right side. So one thing that you have, or you can remember, is the numbers further away to the left is always less than the numbers on the right side. And the numbers further to the right, it's always greater. So I do have those two notes here. You can see right, even though that's not how you spell right, but I put the G so you can relate it to the greater, G. And the left has an L, so you can relate it to the less. So for example, if you look at -5 and -2, well, the -5 is further away on the left side of the number line. So this is less than this number. If you go the other way, the +4 and the -3, well, +4 is further away on the right side, so 4 is greater than -2. Once you know and understand those less than and greater than, well, now you can actually start using the symbols to show which one is greater or less. So this one here, notice that I'm using Pac-Man just as a visual. This is to show you that the Pac-Man is eating the biggest number, and that's what we do. We always have the Pac-Man eating the biggest number. How do we know which one is the biggest number? Well, remember that when you compare the -10 and the -9, the -10 is further away on the left side of the number line than the -9. If you want to look at the number line, I'm just going to draw one up here. So there's the 0, and you can do 1, -1, 2, 3, 4, 5, 6, 7, 8, 9, and then -10, and -9 is before. So the -10 is further away to the left than -9. So that means that -9 is bigger, okay? -10 is less, is on the left side. So Pac-Man is eating the biggest number. And over here, 5, you also can see that 5, 1, 2, 3, 4, 5 is right here, is further away on the right than the -2. -2 is right here. So it's on the right, further away, so the 5 is bigger. Pac-Man is eating the biggest number. So we use those symbols to show the numbers that are less than, greater than. Now one thing that you also have to understand is when you read that symbol, this means less. -10 is less than -9. And when you see this symbol, 5 is greater than -2. That's how we read that statement. We also have perfect square numbers to approximate some radicals. So notice that I give you guys a list. Every number here, it has a square root. They're perfect square numbers. For example, the square root of 25 is 5, the square root of 64 is 8, the square root of 121 is 11. So all of these numbers here, and there's more, the list keeps going, but those are perfect square numbers and they have a perfect square root. So once you know those perfect square numbers, you can start approximating the value of a square root, or we also say radical. But let's talk about less than and greater than for some examples. So this example, you want to replace the box with a less than, a greater than, or an equal if the numbers are equal. So the first example, I have two fractions, 2/3 blank 5/6. So this is one way you guys can find out which one is greater than, which one is less than. You can cross multiply and check which side is bigger, which one is less. But there's a trick. You always have to start from this top number and multiply with the number across on the bottom. You always start with this number on the top. So once you multiply 2 times 6, I'm going to put that number down first. And then I'm going to put the box again because I don't know the second number on this side. Then you are going to multiply the 5 times the 3. 5 times 3, 15. So once you see those numbers, it's a lot easier to understand which one is less, which one is greater. So obviously, we have 15 is greater, so it's Pac-Man is eating the 15, and 12, you can say, is less than 15. 12 is less than 15. So that works. When you go back to the fractions, go back to the fractions 2 over 3, you can put is less than, and you put 5 over 6. So this is one technique to check which symbol you must use. Now, sometimes you don't even have to cross multiply, okay? So if you look at these two fractions, notice that we do have a positive fraction. The first one doesn't have a negative on the left side, so this is positive. Now this fraction is negative. Let me circle that. It's a negative fraction. Positive are always bigger, greater than negative numbers. And it doesn't matter if it's a fraction or a decimal. So right away, I know that this fraction, positive 3 over 5, is greater than negative 2 over 3. Because this fraction is a positive and this one is a negative. Positive are always greater than negative. Now this one here, you can do, since they have the same sign, you can really say which one is less or greater than, but you can do the cross multiplication that I showed you in the first example to compare the numbers. Always remember that you want to start from the top over here, and you are going to multiply the one across from that number. Now all you do with the signs, since we have a negative right here, you are going to just keep the sign and you're going to multiply the two numbers, 5 and 4. So I'm going to bring the negative here. I multiply 5 times 4 is 20, and then you are going to keep this negative over here, negative. Let me draw the box in the middle because I don't know which symbol to use yet. And then I multiply, so I bring down the negative and I multiply the 5 and the 11, which is 22. Now comparing those two numbers, you can see that negative 20 is on the right side, the negative 22. So that means that negative 20 is greater, is on the right. And I'm talking about the number line when you guys compare the numbers. Just to show you guys the number line, there's the 0. I'm not going to do all the little units here, but let's say that I go negative 1, negative 2, and I'm going to approximate negative 20s here. But I have to keep going to get to negative 22, which is here. So this one and this one. Negative 20 is on the right side of the number line, so it's greater. Negative 20 is greater than negative 22. So the answer for this example is greater. Now sometimes you have a decimal and a fraction. It's a lot easier if you guys have a fraction compared with the fraction, a decimal compared to a decimal. So I know you might not have a calculator, but 0.25 as a decimal, that's one of the popular ones or the most common ones we use in math. So that's equal to 1/4. 0.25 is 1/4. I have my box and I have my 2 over 8 over here. I'm going to cross multiply. Remember, you start from the top here and you go to the bottom. So that's going to be 8. And then you multiply the 1 up here and you multiply by the 1 on the bottom. And that's 8. Look at the numbers. 8, 8. So these two numbers or fractions are equal. 1/4 equals 2/8. When you want to estimate the square root to the nearest whole number, this is what you can do, and this is without a calculator. You have to understand the perfect square numbers. So I'm looking at the first square root on the left side, the square root of 15. I notice that 15 is really close to 16, and that is a perfect square number. So the square root of 16 is on the right side of the 15 if you think about the number line. And then I look at another perfect square number that's before the 15. And the number before 15, which is perfect square, that's going to be 9. So if you think about it, the square root of 9, we know that's 3. And the square root of 16 is 4. 15 is closer to 16. So we can say the square root of 15 is right in the middle, and that's going to be 3.9. So we approximate that the square root of 15 is 3.9. Now it says up here that you want to estimate to the whole number. So since 3.9 is closer to 4, you can say it's approximately 4. Now the symbol that we use for approximation is not the equal sign, but we use this symbol here. So the square root of 15 is approximately 3.9. Now, if you look at the next one, the closest perfect square number to that number 167 is 169 and the square root of 144. I know the square root of 144 is 12 and the square root of 169 is 13. But since this number is really close to 169, I'm going to say that the approximation, and I might be off, but more or less the approximation is 12.9 again, because 167 is closer to 169. Now what about the next one? The square root of 111. Well, I know the perfect square number 100 is close to 111, and the next one is the square root of 121. That is a perfect square number. Guess what? 111 is in the middle of 100 and 121. So when I look at the square roots, the square root of 100 is 10. The square root of 121 is 11. So this one is approximately in the middle, 10.5.